This project uses the circuit you previously built with 2 buttons and 1 LED. We're only going to use the top button for this code, but you can rework that code to use the second button as well. So let's go ahead and get started programming. So here I am on the Pi, and I've already opened Python 3. I'm going to do File, New Window, and start a fresh program. As usual, we start with import rp.i.gpio as GPIO, and I also need time, so I'll put comma time. Then I need gpio.setMode, start parenthesis, gpio.bcm. As for variables, we have LED1 again, which is set to 23 because the LED is attached to pin 23, and we're going to have button 1 set to pin 24. I want to add in a couple other unique things. Particularly, I want to have an LED1 state, which you've seen this before in the counter variable video, and we're going to set it to false. LED1 state will toggle on and off so that we can switch the LED from an off state to an on state, and from an on state to an off state, just alternating true and false. I also want to add the pressed variable, which last time we set to false, and we're setting it to false again because we're using a pull-up resistor. There are 2 new variables I'm going to use. First is button1 state, and I'm actually going to just set this to true, since the button's original state will be true because the button is not yet pressed. This variable is going to hold basically a new button state every time we pass through the loop, and we're going to use that as a comparison so we can see whether or not the button state has changed between passes through the loop. So how are we going to know whether or not it's changed? Well, we're going to also store the last time through with previous B1, which I'm going to set to true as well, starting out this program. But you're going to see that I'm going to continually update button 1 state and previous B1 by having them change as we pass through the loop. That's how I'm going to store the value of what was the last state of that button, and it hasn't changed, therefore if it does change, let's change the state of the LED from off to on and on to off. Let's go ahead and see how the rest of this comes together. I definitely need to do the setup lines, so gpio.setup, we're going to set LED1 to gpio.out, and also an initial value of 0, so the LED is originally off, and also gpio.setup button 1 gpio.in. I'm not using the internal pull-up resistor because I have it hardwired on the breadboard. I'm going to do another try except, so I'm going to bring back try, colon, and then I want to use a while true infinite loop. Remember, we're going to use the except keyboard interrupt so we can break this while true and still use gpio.cleanup. The first thing I want to do inside of this loop is update button 1 state. So I'm going to put button 1 state equals, and then we're going to actually read what is the current state of button 1. gpio.input button 1. Now why do I want to store this variable? By storing the actual state of button 1, I can then do a comparison to its previous state and see if it has changed. What I want is to make it so that if you press the button, the light turns on and it doesn't turn off until you press the button again. And this is how we're going to accomplish that. Is we're going to store the current button state and compare it to the last button state. So the first thing through this loop is storing the current button state. So how am I going to know whether or not the button state has changed? Well, we're going to do a comparison. I want to say if, and I'm going to say previous B1, that's where we're going to store the last button state, and I want to compare it to the current button state. But I don't want to know whether or not they're equal, I want to know if they're not equal, because I want to see if they've changed. So I'm actually going to use an exclamation point equal sign. That stands for not equal. Sounds a little bit different than what you're used to, but we can't actually put a slash for the equal sign, so we use the exclamation point. So not equal to button 1 state. So first I want to see, hey, are they different? But I don't want to just know, has it changed between pressed and unpressed, and then unpressed to pressed. I only am concerned about whenever it goes from unpressed to pressed. I want to make this switch literally toggle the state of the LED. So whenever I press that button, I want it to turn from off to on, and then I don't want it to turn from on to off until I press the button again. So I want to actually put a second condition here, so I'm going to join it with AND. Okay, see how that AND turned orange? And I want to say button 1 state is equal to, comparison, double equal sign, the pressed value. So this line is only going to trigger provided that both the previous state and the current state don't match and the current state is pressed. So we have two conditions that must be met. And the next line it's going to execute, if those two conditions are met, is that LED 1 state is going to change. So if you recall from the counter variable project, or if this is the first time you've seen this, is that we're going to use LED 1 state is now equal to not LED 1 state. This will actually make it so that it toggles from false to true and true to false. So no matter what state it is, whenever it comes to this line, it's going to flip to the other one every time it passes through this line. And then I want to broadcast that state. So I want to actually say GPIO.output LED 1 and then the new LED 1 state. Now notice how these are both indented underneath the if. These two lines only run when the if condition is met. So this change in the LED state and broadcasting the new state only occurs every time the button's been pressed. This ensures that we're not continually broadcasting that change in state over and over and over again. It's only going to happen when this if condition is met. So now I can take away that indent and go back, and at this point I need to finish out this loop. Because remember I said I was going to store what was the previous button state. So I want to say previous B1 is now equal to the current button 1 state. So now that I've finished the loop, well, I've finished the if part of the loop, I'm going to now store the old button 1 state so that I have it ready for the next time we go through this loop. Now this last part, I want to give it a little bit of a pause. Time.sleep, and then I'm going to go to 0.01. Now that's a small amount of time, but this actually makes a big difference. If you don't have this line, you'll notice some glitches in the running of this program. Sometimes it won't take when you go to hit the button. If you let go too quick or if you hold it down too long, sometimes it can get a little bit weird in reading that button. Putting this little sort of bounce time here ensures that it reads clearly. So it's just a tiny fraction of a second, so small that you and I would never notice it, but to the computer and to the path of the current, it makes a world of difference. So I need to wrap this up with the except line. So we're going to put except keyboard interrupt, and then we'll finish this out with gpio.cleanup. This program is done. Let's go ahead and hit File, Save As. And we're going to call this button state. And go ahead and hit Save. Open up LX Terminal, and let's get ready to run that code. Sudo Python 3 button state.py. Let's hit enter and see how our project runs. So as you can see, the LED is not lit. What I want is to be able to press the button one time and have it stay on. So let's see if this works. There we go. I just clicked the button once and the LED stayed on. Now when I click it again, it should turn off. So now we're actually changing the state of the LED by doing this comparison between the states of the button. If I hold in the button, you'll notice that it just stays on until I let go again. And if I hold it in again, it stays off until I let go again. So it will not change the state until the button is released and pressed again. This actually makes it really nice that I can click really fast and it will continually be accurate. So if you count in your head, like I'm going to do just 3 fast clicks, it should change state from off to on if I'm doing odd numbers. If I do even numbers, it should be the same state as when I started. So I did 4 that time and it's still on. So if you want, you can try to beat the timer there. You're going to have to be faster than 0.01 seconds to be able to mess this thing up, but it's extremely accurate and it works very well. So let's go back to LX Terminal and use Control-C to end the program. This comparison of button states is very useful when making interactive games out of buttons and LEDs. It's a technique we call polling, because it continually is checking the state of that button and waiting for some kind of change. You're going to hear about polling again in future videos. I hope you enjoyed this project, and thank you for watching.